Hello. In this video, we're going to review factoring. Now, to get into the factoring itself, we have to first talk about a polynomial. So, you've seen polynomials before in mathematics. This is an example polynomial, and to give it a definition, well, a polynomial is just a bunch of terms, maybe an, x to the n, plus an minus 1, x to the n minus 1, plus all the way down until you get to maybe a2, x to the 2, a1, x, and then a0. That's a polynomial. And all of these an minus 1, all the ai's are coefficients. And the goal of a polynomial is to ultimately factor it, but before you do, you need to talk about a few features. You need to have a common language. So for example, if we're looking at this polynomial here, we definitely can see the coefficients, the -3, the 5, the -4, and the -3. And we also can see what's called the degree. If you notice the highest power here, because this polynomial is written proper, we have x to the 4, then x to the 2, then x, then the constant term. It's written in descending order. And so we can quickly recognize that this 4 represents the degree. The degree, of course, is the highest power of x. And there are other things that you can notice. For example, this polynomial has a constant term of -3. It has a leading coefficient also of -3. And there are other things you could talk about as well. For example, there's a missing power of x to the 3. The coefficient there would be 0. Now, let's talk about the root of a polynomial. The root of a polynomial. Well, a root is simply a number that makes the polynomial 0. So for a definition, we could say a root is a real number r such that p of r is equal to 0. So let's say somebody gives you the polynomial 2x squared minus 5x plus 2. Is x equal to 2 a root? Well, to find out, we would have to go ahead and calculate p of 2. So p of 2 would give us 2 times 2 squared minus 5 times 2 plus 2. 2 squared is 4 times 2 is 8 minus 10 plus 2. Sure enough, we get 0. So yes, x equals 2 is a root. Now, once you know a root, you can go ahead and factor the polynomial quite easily using, of course, synthetic division. So synthetic division, it allows you to divide a polynomial by a factor, and the roots generate those factors. So in our case, since x equals to 2 is a root, therefore, x minus 2, basically you just take that 2 and move it to the other side of the equation, x minus 2 is a factor. And since we know one of the factors, we can use that to do factoring. And we use the method of synthetic division. So we're going to take this polynomial here, and we're going to go ahead and set it up. So you get a 2, -5, and 2. You grab the coefficients. Then you grab the root that went in, 2. And you go ahead and do a little series of steps. Hopefully you remember from grade 12. First, you just take this number 2 and it drops straight down. So the number 2 drops down. Then you have to multiply up. So you take the 2 down here and multiply the 2 up here, giving you 4. Again, you drop down, but in this case, you're technically adding as you drop down. So you're doing -5 plus 4, which will give you -1. Again, multiply up. 2 times -1 will be -2. And then you add down, giving you 0 in the end. And I like to box off the ending part. Of course, this should be 0, because if it's not 0, then it wasn't a root, but we knew it was going to be a root, so this, of course, here should be 0, which it is. And then we can interpret this as follows. Up here, this 2 means we have our x minus 2 as a factor. And this 2 subtract 1 means we have 2x and then subtract 1. And there we go. This right here is the factored version of this. So we've successfully taken our polynomial and we factored it into x minus 2 and 2x minus 1. So we could even put an equals here if we wanted. And of course, if you wanted to, you could go ahead and actually multiply this out. If you did some FOIL here, you'd find that this takes you back to this. So let's try another one. Let's try dividing 6x cubed minus 4x squared plus 3x minus 2 by x minus 1. Now, in this case, we don't know if we have a root or not. We're kind of flying blind here. So we're going to go ahead and set it up and see what happens. Again, when you're putting the number in the top left corner, if it's x minus 1, you have to flip the sign, and it's positive 1. All right, so 6, 2, 2, 5, 5. Oh, we got 3. This is not 0. Well, in that case, it means that you can't really use synthetic. You found something here, x minus 1. So x equals 1 is not a root. So we can't use the factor x minus 1 to try to factor because, well, it's not a factor of the polynomial. We'd have to try something else. And now you might say, well, I guess you could try maybe x equals 2 or x equals 3, but there's a lot of numbers out there to try. How would you be able to factor this? What numbers could you try? What numbers should you try? I mean, there's a lot of numbers out there. Is there some kind of method for narrowing it down? And indeed, there is. So the method for finding the rational roots of a polynomial is as follows. Step 1 is to find the factors of an. That's going to be that leading term. Then find the factors of a0. That's going to be the constant term. The possible roots are then going to be of the form, the factors of a0 over the factors of an, and we check the roots with synthetic. Now you might remember from pre-cal that we often had polynomials that didn't look quite like this. We usually had a 1 in the front, and the rule was we'll just look at the factors of that constant term and those are the possible roots. That's the easier version of this from pre-cal, where the leading term here is 1, and so you could think about the denominator of this fraction just being a 1. It's kind of a simplified version. Now that we're in calculus, we're looking at the full version. So we don't just have a 1 up here. Sometimes we have a 2 or a 3. But it's the same method as you would have done with pre-cal initially. You have the factors of this leading or this constant term, and you also include the factors of this leading term. And then you just put them in ratio to one another. So let's go ahead and take a look here. So the factors of the 2 are going to be plus minus 1 and plus minus 2. The factors of the 3 are going to be plus minus 1 and plus minus 3. So let's go ahead and set that up. The possible roots. Possible roots are, well, I usually write it like this. Plus minus 1 plus minus 3 over plus minus 1 plus minus 2. Now you kind of got to put commas there, and this is a bit incorrect in terms of notation, but I'm trying to show that we have all the possible combinations of these. So what this would give is we could look at the 1 over top of the 1, or the 3 over top of the 1, or the 1 over the top of the 2, or the 3 over top of the 2. So 1 over 1 gives 1, so we get plus minus 1. 3 over 1 gives 3, so plus minus 3. 1 over 2 gives, well, a half, so plus minus 1 half. And then 3 over 2 plus minus 3 halves. So there we go. We've got 4 roots, each with their plus minus, so technically 8 possible roots we have to try. So let's go ahead and give them a whirl. Let's go ahead and start with maybe x equals to 1. That's usually a good root to start with. X equals 1 is a good possible root to begin, so let's set it up. We have 2, 5, -5, -5, and 3. And we're going to try our root of 1. So we'll get 2, 2, 7, 7, 2, 2, -3, -3. Hey, look, we got 0. So that means, therefore, x equals 1 is a root. So that's fantastic. We found one of the roots, but we need to factor it all the way. We need to keep going. So we now need to take this new polynomial and figure out what the roots might be for that. So we can write it out just so we can visualize what we have here. This is a -3, 2x, 7x squared, and 2x cubed. So we need to find the possible roots for this one. Maybe we could go up the number line. We could try the number 2. So we'll set it up over here. Make a little bit of space. 2, 7, 2, -3. And we'll try 2. Oh, we shouldn't try 2. That's not even one of the possible roots. We'll try 3. So 2, 6, 13, 39. Oh, this isn't looking promising. 41. Well, whatever 41 times 3 is minus 3 is not going to give me 0. So that's unfortunate. It doesn't look like 3 is going to work. So we should probably erase that. Try a different root. Now, you could go to the fractions, and the fraction roots are great. There's nothing wrong with those. Or you could go to the negative numbers. It's up to you. I'm going to try the fraction root. So I'm going to go with 1/2. So we'll get 2. 2 times 1/2 is 1. Then 8. 8 times 1/2 is 4. 6. 6 times 1/2 is 3. Hey, look at that. We got ourselves a root. That's good. So therefore, we've got x equal to 1/2 is a root. Now at this point we might be able to actually factor this just using our regular knowledge of factoring. This is a 2x squared plus 8x plus 6. And so you could keep trying roots, or you could realize that, hey, we've got a quadratic, we could factor out a 2 as a common term here. And then two numbers that multiply to give 3 and add to give 4, well, it looks like x equals 1 and x equal to, or not x equal, I should just say the number is 1 and the number is 3. So 1 times 3 is 3, and 1 plus 3 is 4. All right, and to get our final factored version, we need to add in those two roots that we had. So therefore, we'd have x minus 1, x minus 1/2, and then 2x plus 1, x plus 3. There's our fully factored polynomial. Quick multiple choice question here. Which of the following is a root of x cubed plus 3x squared minus 4? Go ahead and pause the video and give it a try. All right, so you need to go ahead and plug in each one of those values. And if you plug in -2, either doing synthetic or just plugging it in, maybe we'll do synthetic with it. So we've got 1, 3, 0, -4. There's that missing term. Plug in -2. We're going to get 1, -2, 1, -2, -2, 4, 0. So there we go. X equal to -2 is our root. For homework, go ahead and try these 3 polynomials and go ahead and factor them all the way. To check your answer, you can use the internet. So Wolfram Alpha is an excellent website for doing mathematical calculations. It will solve equations for you. It will factor things for you. Some other people use websites like Symbolab. You can use whatever you want. Just find somewhere on the internet that factors a polynomial. And the way you type in the powers is you use the little hat button. So it's x hat 3, which means x to the power of 3. So if you just type in factor and you type in the polynomial, the internet will factor your polynomials for you, and then you can go ahead and check your answers. So hopefully you enjoyed this video, and as always, thanks for watching.